In this video, I want to give a little bit of intuition about how to find volume of a shape using its cross-sectional area. So I think the best way to start this is to just build a shape. So we're going to start with a curve in a plane. I chose the square root of x. It's not really important. And we're going to consider the region between that curve and the x-axis from some interval. So that's this gray region here. And so what I'm going to do is I'm going to tilt this plane like so. And I'm going to stack some squares on it, like that, right? And so I'm going to keep stacking those squares at those places in the region. And when I do that, let's see here, what do I get? So I get another one. And then I just keep stacking more and more and more and more and more. And notice that the more squares I get, the more this starts to look like a volume. So it almost looks like a three-dimensional figure if I spin it around here. And it turns out that if I, put infinitely many squares here, I end up with this volume here. And so here it is. This is a three-dimensional shape that's created by stacking square cross sections perpendicular to this axis. And so that's what this looks like. Let's see here. So when I had my squares here, the idea was that I can add up all of the areas of these infinitely many squares and get the volume of the figure that I end up with, this limiting figure here at infinity. Let's see here. There it is. So I can get the volume by adding up infinitely many areas. And the way we add up infinitely many things is integration. So we're going to take a look at how we can use integration as a tool to find the volume of a solid made in this way. Okay, so we're going to apply that intuition to this problem here. I want to find the volume of a solid with base in the plane, bounded by the functions f of x equals the square root of x, and the x-axis on the interval 0, 4. It has square cross-sections perpendicular to the x-axis. So let's draw what we're talking about here. And now this picture is going to look really similar to what I just showed you. So I'm going to go ahead and draw this in 2 and 3 dimensions. And so let's consider we have from 0 to 4. So this is my region here that I care about, all this right here. And then it would look something like this in the plane. Now I'm stacking square cross sections perpendicular to the x-axis. So I'm stacking squares perpendicular to the x-axis, and that looks like this. So the squares will have their base in the plane, and they'll be stacked like this. Or if I was to draw this in 3 dimensions, we're looking at something that looks like this. So this would be one of my squares. So I want to integrate over this region. So I'm going to take the integral from 0 to 4 of all of the little areas dx, because we're integrating with respect to x as we have perpendicular to the x-axis. So I just need to figure out what is the area of each of my individual squares, and I can integrate that to get volume. So let's figure out what these areas are going to be. So it's going to depend on x, because as I change in x, the bases will get larger or smaller depending on where I am in the x direction. So what is the area of a square? The area of a square is its side length squared. So it's going to be s squared. So the question is, what is the side length? Well, if we look here at this drawing here, we have that one of the side lengths is the height of f of x. This guy is f of x. So it's going to be the square root of x. So my area happens to be the square root of x squared, which is just x. So this tells me that my volume is going to be equal to the integral from 0 to 4 of x dx, because this was my area here. Integrating that, I get 1/2 x squared. Evaluated from 0 to 4, that's going to be 1/2 times 16 minus 0, which means 8. So the volume of this shape, the one that I showed you in the intro there, it happens to be 8 units cubed.